Hello, today's lesson is for two multiplying matrices, so this is continuing from our matrix unit. Just hoping you're all having a good day. So the rules for multiplying matrices, the first thing is when we're multiplying matrices, the number of columns in the first matrix must be the same as the number of rows in the second matrix. And the order does matter. So when you're doing multiplying of matrices, you have to make sure that if they tell you to multiply matrix A by B, you do it in that order, and then you have to check. So let me just show you how this might look. So if we have an A matrix and it's a 3 by 4, and we're multiplying it by a B matrix that is a 4 by 5, this is, again, always rows then columns. So this is the column here, and then this is rows and columns, that's the row. These two numbers must be the same, okay, in order for it to be possible to multiply them. And if they are the same, the answer will be A, and if you take away the 4s, a 3 by 5. So 3 row by 5 column. Okay, so these are the same. We do a 3 by 5. Our answer is going to come out to be a 3 by 5. If it doesn't, you kind of know you made a mistake. Okay, so that's the general rules. How do we multiply matrices? So let's kind of set up a problem. So we're going to do A, B, C, D multiplied by E, F, G, H, I, J. Okay, and so the first thing, if we look at this matrix, this is a 2 by 2 matrix, and this one is a 2 by 3. Rows by columns, 2 rows, 3 columns. And so we check these match, so we know that this is going to be okay, and the answer is going to be a 2 by 3 matrix. So how do we find the answer? And I'm going to kind of color code, hopefully, this a little bit for you so you can kind of see what happens. So I like to look at it. So in order to multiply them, for the first matrix, you're using the rows. Okay, so I'm going to circle these this way. And for the second matrix, you're using the columns. So I'm going to circle going this way. If you have a couple different colored pens or pencils, it will be really helpful to do this like this so you can see what's going on. So if you do, I would highly suggest grabbing those. So when you multiply and do the matrices, you're going to take this first row here, A, B, and you're going to kind of think about flipping it. The A is landing on the E, the B is landing on the H. So for the first spot here on the new matrix, we're going to do A times E plus the B land on the H, B times H. Okay, that's the first spot. And then we're going to continue working across. We're going to take that row and we're going to bring it and plop it on the second column. So the A lands on the F and the B lands on the I. And again, it's going to be the sum of those. So A times F plus B times I. Then we're going to do that one more time because there's another column. So we're going to take the A, B, and land it on the G, J. So the A lands on the G, and the B lands on the J. Okay, so there's our 1, 2, 3 new columns. Now we're going to do the exact same thing, but with the second row. So we're going to take the row CD, and we're going to flip it and land it, and C is going to land on the E, and the D is going to land on the H. If you check, your first letters should be different, but the second should be the same in that position. Doing the same thing, the CD lands on the FI, so we should have a C with an F and a D with an I. Again, the second letters match, the first are different. And then we go to the next one, CD lands on GJ, C lands on G, and D lands on J. When you're doing this, you're going to actually be multiplying the numbers. So these will be all number values. You are going to add up the sum of the numbers, and you're going to end up with, if you see, a 2 row by 3 column matrix like we had said. So let's go do some of the I do's, and then we can see if we can figure this out together. So this first section says, determine whether each matrix product is defined. So if we multiply these, is it defined? And if so, what is the dimensions of the product? So this is what we were talking about up at the top. We're going to take the columns of the first and the rows of the second and make sure they're the same. So they are the same. And if they are the same, then our answer is going to be 7 rows by 3 columns. So that's what they want us to do here. So checking this one, is 5 and 5 the same? They are the same. So our answer is going to be 3 rows by 8 columns. And look at the last one. The 1 and the 1 are the same. So our answer is 2 rows by 6 columns. If they are not the same, you just say not defined and you are done. Okay, so now let's move on to next section. We're going to actually start multiplying with the numbers and see this setup. So again, this is where those different colors come in handy. So I am going to circle in blue my rows, and I'm going to do my columns in red again. It's kind of whatever pen I'm picking up, so we can see the difference. And now we're going to set up my matrices. So I'll make my little box here. If I look, this is a 2 by 2. I forgot to check. We should have checked this first. And this is a 2 by 3. So the 2's do match up. And our answer is going to be a 2 by 3. Okay, so 2 rows, 3 columns, just like this is very similar to the example or the generic one I put above. So we're going to multiply the 2 times the 3. And you have a choice. You can actually write that 2 times 3 and write it out, or you can do the math. 2 times 3 is 6. And then we're going to add that to 4 times 6 is 24. Okay, and then we're going to do the same thing. We're going to go from the 2 and the 4, flip and land on here. The 2 on the negative 2 is negative 4. 4 times 0 is 0. And then we're going to do the same thing. Again, stick with the first row first. And the first row ends up in the first row. The 2 times the 7 is 14. The 4 times the negative 5 is negative 20. And now we can cross this row out. We're going to do the second row. So 3 times 3, again, we're just going to the first column. So we're putting this in the first column. 3 times 3 is 9, plus 1 times negative 1 times 6 is negative 6. And then we go to the next column. 3 times negative 2 is negative 6. Negative 1 times 0 is 0. And then we go to the last column. 3 times 7 is 21. Negative 1 times negative 5 is 5. And then we're just going to add these together to get our answer. 6 plus 24 is 30. Negative 4 plus 0 is negative 4. 14 and negative 20 is 6. 9 and negative 6 is 3. Negative 6 and 0 is negative 6. 21 and 5 is 26. So this is your answer right here to the problem. And you can see that it comes out to be a 2 by 3 matrix. So let's look at 8 together. This one is a 2 by 2, and this one's a 2 by 2. Those 2's overlap, so our answer is going to be a 2 by 2 matrix. And so let's set this up. I'm going to use my colors to first do the rows and columns. Row, row, row your boat. Yeah, I know that wasn't funny. Column, column. Okay, so let's start off. Upper corner, we're going to go in the first row, and we're going to use the row in the column. 2 times negative 3 is negative 6. 4 times 2 is 8. We're going to add those together. Then we're going to do the row with the second column. 2 times 0 is 0. 4 times 5 is 20. It's always addition. So now we took care of the first row. We go to the second row. 7 times negative 3 is negative 21. Negative 1 times 2 is negative 2. And then 7 times 0 is 0. Negative 1 times 5 is negative 5. So then we find the sum. Negative 6 plus 8 is 2. 0 and 20 is 20. Negative 21 and negative 2 is negative 23. 0 and negative 5 is negative 5. And we end up with a 2 by 2 matrix. So now you're going to do 9 through 14. Again, always check to make sure you can solve the matrix before you actually do the work. So figure out the dimensions, see if you can solve it, see what size it's going to be, and then do the work. If you can't solve it, you're just going to say that you can't and not go any further. So then number 15, we have 3 matrices given to us. And it says determine whether the equations are true for the given matrix. So we're going to now see if this would be true. So we have to plug in or substitute in our matrix. So A is 1, 3, 3, 1. And then it says we're going to multiply that. So we put parentheses. B is 4, 0, negative 2, negative 1. And we want to add that to C, which is negative 1, 0, 0, negative 1. And then we want to see if that's equal to B, which is 4, 0, negative 2, negative 1, times A, which is 1, 3, 3, 1, plus C, which is negative 1, 0, 0, negative 1, times A, which is 1, 3, 3, 1. So if you look at this, they're kind of looking at the distributive property. A times B, A times C, BA, CA. So in normal operations, we would say, yes, this is equivalent. But they're having us check if it works with matrices. Do these properties work with matrices? So let's do the math out and see. So the first thing on the left side we would do is the addition, right? Because we solve inside our parentheses first. So we're going to leave the outside one as it is. I'm afraid I'm going to run out of room. I'll get scrap paper if I have to. And then we're going to multiply by this new matrix formed by adding these. Remember, when adding, you just add the ones in the same box. So 4 and negative 1 is 3, 0 and 0 is 0, negative 2 and 0 is negative 2, negative 1 and negative 1 is negative 2. So we formed that new matrix, and now we're going to multiply these. So let me get my marks. So we got row, row, column, column. And when we multiply, again, we're going to make a 2 by 2. So we have 1 times 3 is 3, plus 3 times negative 2 is negative 6. 1 times 0 is 0. 3 times negative 2 is negative 6. And then we go underneath 3 times. So that's the first row. So now 3 times 3 is 9. 1 times negative 2 is negative 2. 3 times 0 is 0. 1 times negative 2 is negative 2. And if we add those together and we get the final answer, this would be negative 3 in this corner, negative 6 in this corner, 7 in this corner, and negative 2 in this corner. So that's the answer for the left side, where question is it equal to the right side? So now we got to do our multiplication on the right side. So again, I'm going to circle my rows and my columns. And if we do this out, let's start with our first row. 4 times 1 is 4. 0 times 3 is 3. 4 times 3 is 12. 0 times 1 is 1. And then we go to the next row. Negative 2 times 1 is negative 2. Negative 1 times 3 is negative 3. And then negative 2 times 3 is negative 6. Negative 1 times 1 is negative 1. And if we sum those up, we get 7, 13, negative 5, and negative 7. So now let's do the other set. Row, row, column, column. And we're going to do negative 1 times 1 is negative 1. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 1 is 0. 0 times 1 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. Negative 1 times times 1 is negative 1. And so that's going to be negative 1, negative 3, negative 3, negative 1. And then we're going to add these together. And 7, negative 1 is 6. And 13 and negative 3 is 10. And negative 5 and negative 3 is negative 8. Negative 7, negative 1 is negative 8. And if we look, These are definitely not equal. So the answer is no. So if we distribute, and if we look at this A times B, A times C, but they switch it to B times A and C times A, the order, as I said before, on multiplication with matrices matters. You cannot switch them. Whatever one's listed first needs to come first. So that's what that's showing you. Okay, so then you're going to do 16, which is the same idea but much shorter and easier. This is just checking the order. So plug in and do the AC and then the CA and see if they're the same. We've already talked about how they probably won't be, but see if you can figure that out. And then number 17, we are using a problem here. For their 1 week rentals, vacations, the Montoyas can rent a 2-bedroom condo, a 3-bedroom condo, or a 4-bedroom condo. These are the prices. The table shows the number of units that are available to rent from the different complexes. We're going to write a matrix to represent first the number of units. So let's make a matrix out of this. So we've got 36, 24, 22, and then we've got 29, 32, 42, and then we've got 18, 22, and 18. So those are the number of units, and then they want to do the weekly charge. So the weekly charge for each unit, $17.96, $21.65, and $25.38. So that's I do, and now it says if all the units in the 3 complexes are rented for the week at the given rates, show the income of each of the 3 complexes. So if you want to figure out how much they're going to make, you take what they're charging by what they have, and you'll get the answer. So do this multiplication problem out. It's 3 by 3 and then 3 by 1, so it'll work. So if you think about a 3 by 3 times a 3 by 1, the answer should be a 3 by 1. Okay, so you do this out, and then it's going to ask you the total income, so you're going to add up your 3 values.